All right, to make a cloud in a beaker, we have our water at the bottom, which is going to add moisture to the air above it. That's going to provide our saturated air up above. We have a bag of ice on top, which ultimately will be acting as our mechanism of cooling. And as we've let this sit here, the air is becoming more humid inside of there. I'm going to add a match. I'm going to light a match. I'm going to add that in. That's going to give us some smoke, which then will act as our cloud condensation nuclei. And so I'm hoping that even with some glare in here, we can see this. So my matches don't light very well, apparently. And there's our cloud. You hopefully can see the vapor, not the vapor, but small droplets, the cloudiness circulating down from above. Moving in there. As the air near the top is cooled. Move that. The air near the top cools, it causes condensation on the cloud condensation nuclei, and then because that cold air is more dense, it's sinking down towards the bottom, and then the water being warmer than the ice, you will see some areas where it's swirling and coming back up. And there's our cloud in a beaker. If I reveal, there it is. All right, so for this next demonstration, I've got a bottle that I have some water in, and I've kind of been shaking it around a little bit to saturate this. And so as we've said in the past, for clouds to form, we need to have very humid air. We need to have cloud condensation nuclei, which I'm going to light a match and throw it inside the bottle here to make some cloud condensate, or to give it some cloud condensation nuclei. And then the last thing I said that we needed for clouds to form was a mechanism of cooling. And so right now I don't have any ice or anything like that around here, so I'm going to squeeze this bottle. And as I squeeze it, this is representing high pressure. As air is sinking down in the atmosphere, it's getting compressed, it's warming up, and so you see nothing much is happening. Now when I release the bottle, that's going to represent low pressure. And low pressure is rising air, and as air rises, it expands, it cools, and when it cools to the dew point, you get a cloud. And I don't know how well you can see this or not, but there's a cloud in here. When I squeeze it, high pressure, the cloud disappears. When I let go, low pressure, it evaporates. So high pressure, low pressure. High pressure warms up, relative humidity drops, cloud evaporates. Low pressure, the temperature cools down, relative humidity increases, water condenses, and we have a cloud. And now we're gonna go ahead and release our little cloud. that's a cloud in the bottom.